Alright, this is lesson 7.2, talking about absolute value and step functions. So last lessons we talked about vertical and horizontal lines and how we graph those. Now we're going to talk about how we graph absolute value and step functions. So those are your two main focuses today on this lesson is absolute value functions and step functions. So let's take a look. There are two very interesting functions that can be considered related to linear, the absolute value function and the step function. Let's start with the simpler of the two, the absolute value. So example 1, the absolute value gives us the size or magnitude of a number. If we remember, absolute value, I'll write it down here. Absolute value does give us the size of a number, but a way you guys have learned it is it basically turns the number inside to positive. So whatever number is inside of the absolute value symbol becomes positive. So let's see how that looks in these exercises. So letter A, the absolute value of -7 just becomes +7. The absolute value of -2 just becomes +2. The absolute value of 6 becomes 6, and the absolute value of 0 is just 0, because they're already positive. So that's finding the absolute value of something. Okay? A couple other examples really quick before we go to the next part, just to refresh. I'll write them down here. Let's say I had the absolute value of -7 plus 2, and I wanted to simplify this. You'd treat it like parentheses. You'd do what's inside first, so -7 plus 2 is -5, and then that would become +5. Okay, same thing as if we had a problem like 7 minus 2. It would be the absolute value of 5, which would give us +5. Okay, so I just wanted to do those two couple examples because the next exercise goes into graphing, and I wanted to make sure we understand how things simplify inside the value. Okay, so remember, absolute value turns the number inside to positive. All right. So let's take a look at exercise 2. That was easy enough. Now what does the function look like? So an absolute value function is going to look very unique, and we're going to explore that in this exercise. So consider the absolute value function f of x equals the absolute value of x. Very basic. We're not adding anything or multiplying. So letter A says evaluate f of -7 and f of 4. So f of -7, remember that what's inside is like saying x. So this is like saying f of 7 is the absolute value of 7, because this is the function we're looking at right here, that right there. When I simplify f of absolute value of -7, I just get +7. When I simplify the absolute value of +4, I get +4. Okay? Now letter B says, fill out the table below and graph the function over this interval. This should be really quick. And actually it is pretty quick, because if we're just taking, remember, we're really finding the absolute value of x right here. So if we're just taking -3, we're going to make it +3. The absolute value of -2 is +2, and so forth. We're just making all of these and keeping them positive to find our y value, right? We're plugging something in and finding our table. So very quickly I found my x's and my f of x, remembering that f of x is another fancy way to say y, and with this table I've created a set of coordinates, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Remember, a table creates coordinates. So now that I have these coordinates, I can graph them. So -3, 3, -2, -2, -1, -1, 0, 0. So I'm right now I'm just going through and I'm graphing each of these points. I've graphed these first 4. Now I'm going to graph 1, 1. That's that point right there. I'm going to graph 2, 2. And 3, 3. So this is my absolute value function. Okay, absolute value functions, and let's write this down. Absolute value functions will always look like a V. Okay, no matter what, it will always look like a V. Okay. that they just always look like that. One line slanting downward, one line slanting upwards looking like a V. They always look this way. It might be up more, to the left more, to the right more, somewhere else on the grid, but it will always look like a V every time. So letter C now says, what is the minimum value of the function on this interval? Well, remember, minimum means the lowest, so there's my minimum at 0, 0. So my minimum value is 0. Easy. Over what domain interval is f of x increasing? So remember that domain means what? Domain means our x values. And I want domain notation, so it's going to look like this. Where is it increasing? Well, it's increasing from here to here is where it's increasing. So that's from x equals 0. So from this point right here all the way until that point at 1, 2, 3. Okay, you could also write it in this notation. Remember that notation is important when talking about domain and range. Okay, there's two different ways we can notate it, and both of these ways will work. Okay, so that's absolute value functions, graphing. The last thing let's look at for exercise 3 is an algebraic exercise with absolute value. So exercise 3 says, for the function of f of x equals absolute value of x minus 4 plus 7, which of the following is the value of f of 1? So I'm going to say f of 1, and this means that I have to plug in 1 for x, so I'm going to have 1 minus 4 plus 7. And now I'm going to simplify. Like I said before, you do what's inside the absolute value first. 1 minus 4 is negative 3. And then the absolute value of negative 3 is really positive 3. And 3 plus 7 equals 10. So I get this for an answer. And you could graph this function, totally easy. You just have to make a table, find out all your x's and your y's, and graph it the same way we did the one before. Okay, unfortunately, the calculators you guys have in school don't graph absolute value or step functions. That just is not there, that it's disabled for testing mode, so this is something you have to learn to do without the calculator. So that's kind of why I thought it'd be okay to do it for a take-home, because you can't use the calculator on the Regents for this portion anyway. Okay, if you do run into trouble, there are calculators online. You can check your work. You can always find one, but on the Regents, they won't have one available for you. Okay. So let's take a look at the second aim today, and that's step functions. So step functions are super weird. So I'm going to take this kind of slow. Step functions are another type of function that related to the linear family. So step functions are unique. They're related to lines, but they're not quite lines. Its graph is going to really reflect its well-chosen name. They're going to look like stairs, like steps, actually. Like you could go up steps. That's why it's called a step function. So exercise 4 says, consider this step function given by f of x equals 2 between 0 and 5, and f of x equals 6 between 5 and 10. I know that you guys have struggled a lot in just reading what this is. Remember that this portion right here that I'm going to underline, that tells you the interval when it's 2. The interval when it's 6. That's not telling you what the graph looks like. It's telling you where it's 2 and where it's 6. So let's first of all do letter A, where it says evaluate each of the following. After you do your evaluation, write down the coordinate point that must lie on the graph as a result of the calculation. So let's do this really quickly here. F of 0. So the first thing I'm going to do is I see 0. Does that go into this top one, or does that fit into the bottom one? Well, 0 fits into the, you know what I'm going to do actually? Let's change these colors around. Okay. I'm going to make this first part of this purple. Okay, I'm going to make that first interval purple, and I'm going to make the second one blue. So now when I ask, where does 0 fit? Does 0 go in between 0 and 5, or does 0 fall between 5 and 10? Well, 0 falls between 0 and 5, correct? So that means it must be 2, because it falls in between 0 and 5. That coordinate is 0, 2. Let's take a look at the second one, f of 2. Does the number 2 fall between 0 and 5, or fall between 5 and 10? It falls between 0 and 5, so it's got to go with 2. So f of 2 is 2. F of 4. Does f of 4 fall between 0 and 5, or between 5 and 10? It falls between 0 and 5, so that goes with 2. these coordinates would be 2, 2, and 4, 2. Now when we get to the next one that says f of 5, we have to read very carefully. F of 5 equals, see how this does not have, it doesn't have an equal under it? That means the 5 falls here with the 6. So f of 5 is 6. Okay? F of 7, does f of 7 fall between 0 and 5 or 5 and 10? The number 7 falls between 5 and 10, so it goes with 6. And finally, f of 10 also goes with 6 because it falls between 5 and 10. So, we have all of these. Okay, I know that interval notation is really kind of hard to get used to. And this is also kind of hard to get used to because we're not actually plugging any numbers in, right? There's no x value here. We're not actually plugging an x, we're just looking at where it's defined in the interval. Okay, so it's kind of a different way of reading this notation. Okay, now that I've got all 6 of these points, I'm going to graph my function onto this grid. Okay, so I'm going to graph the purple points first, so 0, 2, 2, 2, and 4, 2. And then I'm going to graph 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, 5, 6, 7, 6, and 10, 6. Okay, now step functions are very strange. I'm going to erase this up here really quickly. Do you see here where I'm going to go back to making it purple and making it blue? Before we connect these dots, which connecting the dot is the hardest part, notice I'm going to draw your attention again to the fact that there is no underline here. It's missing. Because there's no underline there, I'm going to draw an open circle at 5. Actually, I'm going to make that a little bit easier to see. There's an open circle at 5. The rest of these all actually hit, but since at 2, and keep in mind, this is at 2 here. That's, 1, 2, 3, 4, 5, 6. At 2, it does not actually equal 5, so I put an open circle, and then I connect it. But once I get to 5, see how there's an underlined 5 right here? That's a closed circle at 5. So I'm going to make a closed circle at 5 and then connect my dots here. Okay? Step functions will always look like this, where it has where two things that fall on top of each other. Let me draw this quickly. If these lines fall on top of each other, one will be an open circle and one will be a closed circle, right? Otherwise, it's not a function, because we've talked about this. If I were to draw a vertical line down this and it touched 2 points, it's not a function. It can only have one input, one output. If this was a closed circle, if I filled this in right here, then it would have 2 outputs. It would have an output at 2 and an output at 6, and that can't exist. So we make an open circle there to show the step. Okay? Now, where do we ever see a step function arising in the real world is the question. Because, there is a purpose to step functions, and they are very rare in Common Core. I don't see them very often. But there might be one per test. And, it's not too terribly difficult to graph once you practice it. And they're always going to give you a contextual situation, a real-life situation. So the last exercise on this lesson is a real-life situation that uses a step function. Okay? And this is one I think that you guys can all kind of relate to, actually. So let's read. At a local amusement park, the park charges an admission based on age. Graph the amount of money a person would have to pay for admission based on their age. Remember that someone who is 1 day short of 4 years can consider themselves 3 and under. So this is where step functions become very useful. When we talk about things like age, where you can't really have a decimal of age to work with. So let's see what this step function would look like. Okay, so if I am here, I hate how these graphs do this. They don't, number everything. Let's number this really quickly, because it's oftentimes very hard for you to imagine this without having all of the numbers in front of you. So really quickly, take a second and let's label these with all of the numbers. Okay. All right. Age is on the bottom, so that's important. So age is on the bottom and cost is on the left. So let's think logically, right? If I am 1 year old, how much am I going to pay? We can make a table here. That might be the easiest way. If I'm 1 year old, how much am I going to pay? let's put age and cost. If I'm 1 year old, I'm going to get in for free, right? So I'm 1 year old, I'm not going to pay anything. So I put a point there. If I'm 0 years old, that doesn't really exist, but we're going to call it a point anyway. I don't pay anything. If I'm 2 years old, I'm free. I don't pay anything. Let's change these F's to 0, right? The cost is 0. If I am 3, this says 3 and under. So if I'm 3, I'm still getting in for free. So I'll put another thing on 3. But the minute that I hit 4, how much do I have to, am I still free? No. The minute I hit the number 4, how much are they going to charge me? They're going to charge me that $4. So when I get to 4 here, I suddenly have to pay $4. Now, we're not going to leave this blank because if I'm 3.5, let's say that I'm, let's move this 4 down, actually. Let's say that I'm 3.5 years old. If I'm 3.5 years old, I'm still actually considered 3, because remember what this says? Remember that someone who is 1 day short of 4 years can consider themselves 3 and under. So even though I'm 3.5, I'm still technically 3. I'm still going to pay nothing. So as I get up here to 4, if I'm 3.9, I'm going to pay nothing. So this is where that open circle comes into play. Because the minute I hit the age of 4, what are they going to charge me? $4. Boom. So I have that step right there at age 4 where I no longer get to get into the park for free. At age 4 in my table, suddenly I'm going to pay $4. Okay? Now, if I'm going to keep my table going here, right? If I'm 5, I'm going to pay $4. If I'm 6, I'm going to pay $4. Where does it start to change? 7, I pay 4. 8, I still pay 4. So let's mark those points. I'm still paying $4 until what age do I get to? I'm still paying $4, $4, $4. When I hit the age, if I'm 8.5, I'm going to pay $4. If I'm 8.9, I'm going to pay $4, right? But what age will it suddenly stop being 8 and under? At 9 years old. I will stop being 8 and under, and I'll be bumped up to the next price, which is $8. So at 9, I suddenly have to pay $8 when I hit 9 years old. So I have an open circle here when I'm paying the 4, and then all of a sudden I have to start paying $8 when I hit 9 years old. So I'm going to have a closed circle on 9. Okay? Then the next big bump is at 16, right? So I'm going to be fine. When I'm 10, I still pay $8. When I'm 11, I pay $8. 10, 11, 12, 13. In fact, I'm not going to even write all these. I'm going to say 10 until 16. I'm still paying that $8. So I'm going to make dots all the way up until 16. And then what age are they going to make me start paying the next one? 17. So I have an open circle on 17 and a closed circle at the new cost of 12 right above it. Okay? And then I'm making, there's no more changes there, so I'm going to have a big arrow. The key places here are these steps right here. These steps, I'm making dotted lines to show you these steps. You wouldn't actually graph them, but notice these open circles. And remember, think about why they're open. If you're 4 years old, you're not getting in for free. If you're 4, you immediately step up to $4. If you're 9 years old, you're no longer 8 and under, you're 16 and under, you're paying $8. So this is a very specific example of where you'd see a step function in real life. Yes, they're kind of strange. They take a little bit of thinking. Notice I didn't really plug anything in. All of my graphing was based on reading the table, the rules of the amusement park, and thinking logically about what makes sense. This is a sense-making problem. Okay? So there's not always a very clear procedure to solve these problems and make these graphs. You have to think and make sense of the numbers. Alright? You can Google a lot of things on step functions if this is tricky for you. You have the internet at your disposal. You have my email, and a lot of you have my phone number. Okay? I'm here for you all week if you need it. Good luck on your fluency, and ask for help. Okay?